Yes. I think you have enough space.
Yes.
Yeah. Okay, you got it? Prove and use the formula here. That's what I'm doing. Alright, you can't quite see it, but look, that's a pendulum. And you're like, what's a pendulum? Well, that's what this guy here is. That's a pendulum.
No.
What do you know?
This is not a stand.
Should I draw this?
No. This whole thing is a pendulum. Yeah. So if you don't know, you can draw the picture. This is a pendulum. Okay. Right, let's have a look at this now. Let me draw it. Okay, pendulum. A little better. So let's say our pendulum has a length L. Now the pendulum is swinging like this. The heck, that's not even straight. Now look, for this proof, you need to say that this is like a triangle, but of course it's not really a triangle because this part here is straight, but this part here is not straight. But that's okay, you say it's almost a triangle, which is fine for this proof.
We can find this other part too.
No, we say it's a triangle. It makes the formula easier to find for the proof. Okay, so look, we'll call this angle here theta, and we'll call this distance here x. Can you see what I'm saying? I'm saying the distance from here to here is x. You got that? Okay. Now what is sine theta here? Sine theta is x over L. Yeah? Okay. Now do you have your calculator? Can you put your calculator in radian mode and calculate this? Sine 0.1. What's that?
1.0.
In radians? Have you got radians?
No. Maybe.
Yeah, see here you have degrees.
Yeah.
So if we go mode, hang on, sorry. Shift mode, and you can make it radians. Now it's radians. Remember radians?
Yeah.
You're starting to forget.
0.09.
1 radian is 57 degrees.
Okay.
57.3.
This one is
Yeah. What's the first one, Claire?
1.099.
Yeah.
No.
850.
No, you're in degree mode as well.
0.099.
Yeah.
0.0998.
Oh yeah, 0.0. Yeah.
0.099.
0.0.
998.
So in other words, roughly 0.1.
The next one is 0.049.
0.049. So roughly 0.05. And this one here?
9.99983.2 minus 3.
That's 75 minus 3.
Yeah, so roughly the same. So this is my point. If theta is small, then sine theta is nearly the same as theta. If it's small, and if we're using radians. Yeah, now you don't need to write this down. This is the key here. I'm going to go back to my proof. I'm saying that if theta is small, then sine theta is roughly equal to theta.
Oh, it's 0.998, 0.49, 0.009.
What? What's wrong? What's wrong?
Same.
0.009 is 999, wasn't it?
Oh, the same thing about
Yeah, alright. Okay, back here. Look please. So, can you see this sine theta is roughly the same as theta then, equals x over L. They're about the same. Okay, now, what force is acting on this? What force? Gravity. So how much is that? mg. So what you can do is you can put this part here, and then this part here, and if this is theta, then this angle here is theta. So is this cos or sine? This is mg cos, and this here is mg sine. You got that? Yes? Now, do you see this force here is making it go to the left? That's the force that's making it go like simple harmonic motion. So let's have a look at this force in more detail. F, this force here I care about. F equals mg sine theta. Okay, so F equals mg sine theta is roughly the same as theta, which is roughly the same as x over L. Now what does F equal? MA. So you can say MA equals gx over L. Oh, sorry, and M here. Now what can I do with the M's? They can cancel. So you have A equals G over LX.
And M is opposite?
No, L is the length of the pendulum, he said. Now what type of motion is this? What type of motion is this? What's it called? Is it circular? No. Is it a projectile? No. What type is this? What do we call it? The last lesson? What was it called? Simple harmonic motion. This type of motion. Like with the spring. Do you have the formula for the A? What was the formula from the A? Do you remember it? V squared over R. Wasn't it? And also, what was your formula for V? V equals omega R. Now watch this. I'm going to put that formula in there. So I get A equals omega squared R squared over R.
So it would be omega R.
So A equals omega squared R. Oh, sorry, this, yeah. No, this, no. This is for circular motion. No, don't pretend like you knew that. What was it so simple? Ace equals minus omega squared x. That's better, my goodness. Minus, yeah. And this force is going to the left, so it's a minus as well. Okay. So look, we have this formula, and we have this formula, and we can put them together. So I get minus omega squared x equals minus g over Lx. So what does omega equal?
G over E.
What is it? Look, the minuses go, the x's go, so
G over E
root g over L. Now what's the formula for t? 2 pi over omega. So here's the result. We therefore have t equals 2 pi root L over G.
That's time.
This is the result.
The formula for time.
Yes, I know this.
Yes, I'm not percent.
The periodic time.
So there's one that,
Wait! This proof is important because this proof needs to be in your report, your lab report. So you need to have this proof in one of your lab reports later. So, let's do some examples. Watch this. This here, can you write this down? The L is, let's see. KJ, come here. How much is the L? 71?
71, yeah.
Right. Now we need to turn the fan off. Okay, so can you write this down? L equals 0.71.
Meters.
L point.
0.71.
Okay.
You got that?
Yep.
Yeah?
0.0.
71. Now, can you use this, what's G? 9.81. Yes? Can you use this formula to tell me what the T should be? 9.81 for G. So tell me the T, please.
Can you just,
T should equal KJ.
oh,
I want the T. You know the L and you know the G and you know the pi.
one thing.
What?
F is equal to mg sine theta.
Yeah?
Which formula is this? Mg.
No, I'm saying that F. This is the force that's making it move. This one going to the left.
1.69.
Oh.
Yeah. Huh?
1.69?
1.69. What did you get?
2.9.
Why can't we just type things in? 2 pi. Now this looks right. What did you type in? I think something's wrong here.
Maybe it's in reading mode.
It shouldn't matter.
Mm-hmm.
I think it's 1.69.
Yeah.
So what did we get? 1.69.
But it's still got down, no?
That doesn't matter for this calculation. Right, so the time here is 1.69 seconds. Look at me, please. So that means if I hold this here, how long will it take to go over and back?
1.6.
1.69.
You can check this.
We can check it. That's what I want to do. So this should take 1.69 seconds. Now, that's going to be difficult to time, isn't it?
Yes.
So this is what we'll do. We'll let it swing 10 times. How long should 10 take?
Take the average.
Yeah, how long should 10 take though?
0.9.
10 should take 16.9 if we do it 10 times.
Yeah, okay.
Yeah, so this is our plan. So can you take out your stopwatch? And we'll see.
Wait.
Some people might be wrong due to human error.
Stopwatch, please. You got your stopwatch?
No.
No.
Which one is 121?
So, look, I'll count them. You just press start when I say start and stop when I say stop.
That's still take some time.
I know, we'll factor it in. Are you ready? What do you need?
I'm going to start so that...
Okay, but I need to do this part now.
Okay.
You all have your stopwatch?
Yeah.
Sophie?
Yeah.
Grace?
I'm finding.
You're finding it? Okay. So, this is what I'll do. I'll say 3, 2, 1, start, and then when I say start, you can press start, and then I'll say stop, and then you press stop. Okay. So, are you ready? Yeah, okay. So, 3, 2, 1, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, stop!
60.62.
15.59.
16.96.
Not bad.
16.5.
I don't think that's bad.
Very good.
Yeah, so 16.7, 16 point, yeah. So you can see, pretty close. It's not too bad. So this formula, even though we have to make an approximation with the formula, you can see it's still pretty accurate. Yeah? Okay. So actually, the example I did wasn't 1 meter, it was 0.71. So let's just do one more example. Can you calculate how long it would take for 1 meter? And I'll measure 1 meter. Yeah, 1 meter and 10 times. 2.006. So about 2 seconds.
2 seconds.
So how long should 10 take? How long should 10 take? 20 seconds. Okay, this is going to be a little bit long.
Okay.
Alright, got your stopwatch?
Okay.
Close enough.
Yeah. Okay.
Alright, ready? Okay. Okay, I'll do the same. 3 and 2, yeah? So, 3, 2, 1, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, and stop.
19.26.
19.86. 20.15.
Huh?
20.15.
20.15, that's better, yeah. So this formula works very well. Can you see that? Even though we have to make an approximation, it still works very well for the pendulum.
You got, I think it's very soft.
Huh?
Oh
Okay.
my gosh.
No. homework. Yeah, I don't do any homework. You do the homework.
No.
No?
Too much homework.
But you have next week off.
But you have
That's
every teacher said next week you have a holiday. Next week you have a homework.
Yep, that's true. Well, look, this isn't as difficult as it isn't as long as it looks. There's the length. So the first question is time.
Oh. We don't have pendulum.
No, but you have the formula. Can we look, please? So first question is the time. So do you have a formula for the time for the pendulum? Yes, you do. We just did it today. Yeah? Secondly, what is the velocity of the pendulum? So you can use the formula from the last class. What's the formula for V? A omega. Yeah? Do you have the A? Look, there's the A there. Do you see this? Amplitude means A.
Yes.
That's how much I pull it out.
The length, yeah.
The horizontal.
Oh, yeah. Oh, what does that have to do with it?
It lets you calculate the speed.
So the time will be the same as
In fact, yes, that is true. The time doesn't matter. So look, as I have noticed, can you see here? It doesn't matter where I hold it, the time will still be the same. So even if I hold it out here, it's still 2 seconds. And if I hold it here, it's still 2 seconds.
Put it over, like...
Okay, there's limits, of course. I can't go too far out. But as long as the angle's not too big, it'll still take 2 seconds.
That's fine. That's fine.
That's more. Wait.
Dude. So even this far might still be 2 seconds.
Start. It's not 2 seconds. Like 1.6.
This question here was an exam question. That's why I wanted to do it. I know. So, well, you only have 2 physics homeworks. There's simple harmonic motion and pendulum. Yeah, and this could be on the exam.
3 math homework.
3 math homeworks, 2 physics homeworks, 7 days.
2 math.
Exam.
No. Exam, we have exam.
Yeah.
We have to practice. Yeah.
This could be on the exam.
Could be on the exam?
Yep.
I bet there was not until geometric.
No, until today.
Math.
Yes.
The exam of math.
Yes.
Why?
Because that's how I am.
Even the logarithm.
Yes.
Look, until geometric. See you in
I'll try to.
I don't have math homework.
I will. See you. Yeah, I know. Yeah. If you have questions during the holiday, you can email me, okay? If you have physics or math questions, you can email me. Please try to do this on the test.
No, we said tomorrow.
If you have questions, you can email me. Enjoy your holiday.
Korean.
Thank you. Thank you. Just my color.
Yeah. Bye-bye.